Here's another example. Okay, just do it the same way we did the other. Okay, this is the same equation we did before. We can see that the intercepts are 6, 0, and 0, 4. Right there's our first line. Okay, I'm going to use a different color, use a color for this one. Okay. If on the second equation y equals 0, then negative 4x equals negative 24. And if you divide negative 24 by negative 4, you get 6. So the x-intercept is the same. Again, if y is 0, negative 4x equals negative 24. X is negative 24 over negative 4, which is 6. So I'm going to use green and say that, oh, look at this. Have we already got our solution? Because the two graphs have to cross at this point. That means 6, 0 works here and works here. And of course it does because of what we just did to find it. Okay? Well, let's find the y-intercept just to see how the two lines are. Okay? Okay, if x is 0, negative 6y equals negative 24, so y is 4. Uh-oh. It looks like the y-intercept is also the same. Okay? So it looks like the two lines are the same. Now, both lines being the same, this means that every point on either line is a solution to the equation. I'll say every point on the common line well, I'm having a fit. In fit. I'm apparently not able to spell infinite. Getting ahead of myself. Okay, so they're infinitely infinitely many solutions of the system. Well, infinitely many solutions to the system. Okay. And that's because one equation is a multiple of the other. If you multiply this equation by negative 2, you get this. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 12, negative 24. Okay? Well, that's all right. That can happen. You can't always see it when one equation is a multiple of the other. Okay? Another example. We'll stick with 2x plus 3y equals 12. And we'll stick with negative 4x minus 6y. But now I want 36. And I'll go with negative 36 just because that'll keep the graph under control. Okay, we know that the first graph goes through the points 0, 4, and 6, 0. So there's our graph of the straight line. The second graph, the x-intercept is going to be 9. I should have extended my x-axis and my y-axis a little further, but now we'll do it. Okay, so we're going to have the point 90 out here, and the y-intercept is going to be 0, 6. Well, that's going to be a little high here, but 0, 6 is going to be up about here. Okay? And if these are graphed accurately, well, the slope of this graph is negative 4 divided by 6 if you do a fundamental triangle, negative 2/3. This would be negative 9 divided by, negative 6 divided by 9. Slope is also negative 2/3. What you have is parallel lines that don't intersect. So there's no solution because there are no common points. Okay? Now, what that is one side of the equation is a multiple of the other, but the numbers on the right-hand side are not the same multiple. In other words, this is 3 times this is negative 3 times this, and this is negative 2 times this. So that offsets the lines. They become non-parallel. Those are the 3 possible things that can happen. If the lines aren't parallel, they have to intersect, and they can only intersect at one point. If they are parallel, either they don't intersect, in which case you have no solution, or they intersect at every point, in which case you have infinitely many solutions. Now there's more, but your text and your problems will bring out those details. Now quickly we're going to look at how you solve these equations algebraically. Very simple.